Greetings hobbyists, this is Arsanzavul, and in this video we're going to create a set of geometry nodes that will procedurally create dungeon floor tiles. So as you can see, we've got this single dungeon floor tile, and we can quite easily move this out and select edges to create a series of dungeon tiles. So we can do something, for example, like that. And then we've got our dungeon tile or our corridor sorted, or we could change that if we wanted to into something like a T-junction and do something like that. So this will quickly generate these tiles, and then this will be 3D printable and something you can use for your dungeon exploring. Now the first part of the video is going to look at how this is created as a geometry node setup, so you can do this yourself, or if you're not really interested in that, you just want to be able to do this because you've got some 3D printing you want to get going on for a nice dungeon adventure, you can download this geometry node setup from my Patreon. There's a link at the bottom of the screen, and if you skip to the chapter at the end, it will show you how to use this even if you haven't got much or any Blender experience. So let's start with the basic setup of this. Now the first thing is you're going to need some tiles. This is what's going to be randomly represented on your floor, and the more you do, the better that randomization is going to be. So I've got 20 here, and all I've done is sculpted some really quick texturing on them to make them look a bit like worn stone. You've got some that look nice and smooth, some that are a bit more chipped and battered, so there's a nice bit of variation there. This is just using clay strips in sculpt mode pretty much. If you want to have a look at how I've done that, there's a video in the description of a past example where I've done that. The other thing that we're going to need is we're going to need to make sure that our object that we're using to procedurally create this is going to snap effectively. So what I'm going to do is Shift A, mesh it, and bring in a plane, and I want that plane to be the correct size. So I've done these tiles to be just under 40 millimeters in diameter, or 40 Blender units, so that there's going to be a little bit of gap. I think they're about 38 millimeters each in size, and I think about 4 millimeters deep there. So we're going to want the same thing here. So I've just brought in this plane, and this is going to be 40 millimeters in size, which means that this is going to work. The next thing we're going to need to do is that we're going to need to make it so that these edges, as we G and move them, are going to, well, move correctly. So what we're going to do is we're going to turn on snapping up here, and we want it to be working to increments. And at the moment, this, I think by default, is snapping to 10 millimeter increments, which we don't want. We want it to snap to 40 millimeter increments so it quickly creates the correct size. So we can do that up here. Now I generally have my floor off. I just find it annoying. But you can turn that on if it helps to visualize it. But if you've got here your scale, you want to change that to 40 or whatever you want your unit to be. And that means that now when I press E, it's going to snap 40 across each time. So whether you keep the floor on and off is entirely up to you at this point. I'm going to turn it back off. I don't like it. So from this point we can get straight on and into our geometry nodes, which is what's going to procedurally create this. So I'm going to move this up. I've got this set for geometry nodes. If you don't, just come down here, click geometry node, and this will come up because you might have it automatically set as a timeline. So let's go back to that. And then let's get rid of the side panel, and we just want to click new, and that gives us this geometry node setup. Now we do want our group input, but we're going to start having to add things in. So we're going to start by making the flooring that's going to act as the base of our dungeon tile. So we need to make this thicker, so Shift and A, and I want to extrude this mesh. So we're going to bring that in there, and that's going to extrude it in this instance up. Now as part of the function of this, we're going to want to use the top of this to where we're going to instance our tiles on that are over here. So we don't actually want this extruding up. I'm going to change this to -2. So that's 2 millimeters. There is something that's important, or two things that is important to see here. And that is that one, this looks hollow. It doesn't keep the original face, but that's relatively easy to deal with. We're just going to bring in a join geometry node, and we're going to put that there. And we're going to connect the original geometry to that. So we're now adding them together. So that is now working. And importantly, and this is why this is key, is that we want to have something separate to work just on the top geometry, which is this bit here. And you'll see why as we come to this. So let's go back to that where we've got this working. Now, if I just turn on my face orientation, you'll see this does cause a problem because it's extruding in the wrong way. So what we need to do is, before we join this together, is flip these faces around, just of this portion where it's not working. So Shift A, and we're going to flip faces and put that in there, and now this is working. I can turn off that face orientation now because we're not going to have another problem with that. Now if you want this to be thicker than 2 millimeters, you can change that here as much as you want. I'm going to leave it as -2. That's what I want this to be. As it will be thicker, thick enough to be rigid, but not so thick that it wastes resin and looks really chunky. So we've got that, and that looks about right. Now, we do have one other thing that we want to do, just to make sure this works, and that is that at the moment, if I go back into edge mode and E to extrude that out, you can see we've got this working now. It's making the base plate for this. Probably actually going to leave this there so I can see how it works. But it is worth noting that if someone's creating something from this, there is the possibility that they might then E and do here, and this is going to cause a problem because at the moment these vertices, so that one there and the one that's under it, are not actually connected together because of the way that we've created this by moving these out separately. So what we actually want to do is merge by distance to make sure that's working, and that will remove any duplicated vertices. It will also stop certain problems, like if for example I press E and then extrude it there but then press escape, the extrusion still happened here, but that will fix that because they're all going to get merged together. So it will solve some of these problems. So that's quite a nice bit to have. So now we need to start instancing on these faces. And to do that, we need to have somewhere to instance to, because normally if I shift A and bring in an instance, we instance on points. And well, at the moment, if we were to do this, there's, well, a lot of different points. At this point, there is, if I go into vertex mode, well, 1, 2, 3, 4, 5, 6, 7, 8 points. So this would look awful, and it's not what we want it to do. We want it to instance each time in the middle of each face. So we're going to just drag this geometry out. Notice we're doing this almost as a separate tree. In fact, let's make that really clear by selecting those, Shift and P to put them in a panel, and then we'll just click on that, press F2 and call that, I don't know, plinth. You can call it whatever you want. So we've got this working, but we need to make sure that there's a vertex on only the center of each of these faces. So let's bring our geometry out, and we want to convert our mesh to points. So mesh to points there. We want to change our vertices to just be faces. So this is going to convert our faces to points. And that means that there's now a point in the center of each of these faces. And normally if I do that, it doesn't really show this very well, so I can't really demonstrate that. But you'll get what we're talking about as we do this, so let's come back to that. Now, so we can see both of these at the same time, I'm going to bring in another join geometry nodes just there so that we can start looking at both of these together. And then finally from this we want to instance on those points that we've got. So we've got an imaginary point in the middle of each of these faces because of our mesh to points. And we want to instance all of the parts of our collection. Okay, so these flagstones. And you'll notice that these flagstones are actually a collection by itself. And I've just realized I've done something wrong. At the moment, this plane is sort of floating in here. We don't want this, so I'm actually going to press M and move it to my normal collection. If we had this as part of the flagstone collection, this is not going to work. It's going to mess up. So that was a bit of a mistake here. In fact, I'm going to F2 and rename this as tiles setup. Whatever. Anyway, so let's get in here and we want to instance something on this. So let's drag our flagstones in here and add that to our instancing, and we need to click separate children and reset children, and we've got those there. This is an almighty mess because all of them are trying to instance on top of each other, so we need to click pick instance, and now it's going to pick an instance. So great, looking really good, except, in fact, let's go into vertex mode and delete these vertices, and then back into edge mode, is that if I start bringing this out, you're going to notice that this is doing this in the same order as these appear over here. So we've got that one, then that one, then that one, then that one, because this is 1, 2, 3, 4, and so on. So we don't want that happening. We want this to be more randomized. So we're going to go to instance index, and we're just going to come out here and random value somewhere in there, and that's now going to randomize this. And what's useful about that is that we've got a seed value here, so if we don't like this randomizing, we can always change it. So that seed's going to be important for our randomization, so we can quickly flip between things that we want. So this is working pretty well at this point. Anytime I select an edge and extrude it out, it's going to create our additional tile, so that's pretty much what we want. But we are going to make this a little bit better at this point. And the way we're going to do that is actually add an extra level of randomization. And the reason I want to do this is because some of these things are fairly noticeable, like that crack there. If it's always in the same place, then it's going to be really noticeable that every time this tile occurs, that indent is on that side or on that side. So what we want to do is we want to rotate these randomly. And we can do that with our rotation choice over here. Now we only want to rotate it along the x-axis, so basically rotating it round from the top down. So I don't need to control all of these, but you can notice I can do that. So we want to control this. Going to put that back to 0 and just drag that out. And to do that, we need a combine X, Y, and Z for vector. So that's going to allow us to do that because we can select only the Z axis. And we want to rotate this round, well, multiples of 90 degrees. Blender doesn't seem to like degrees, which agitates me. It seems to work in radians. My brain doesn't particularly like radians, but either way, we'll deal with it. So what I want to do is another random value, and we're going to set that to be an integer anywhere between 0 and 3. So we've got 0 degrees, then we're going to say 90 degrees would be 1, 2 would be 180, and 3 would be 270. So we've got all of our rotations of 90 degrees to make sure that this is going to stay, well, in a sensible orientation. Now, as I said, we don't do degrees. I wish there was a node for that. Maybe there is a node for it. If there is, let me know. Maybe I'm just missing out on that. But we can just use a maths node to multiply it, put that into the Z value. You'll notice this is not doing a lot, or it's not doing it right, because at the moment it's multiplying it by 0.5. So we want to multiply it by, well, 90 degrees, and 90 degrees in radians is just pi divided by 2, and now that's going to work. So you'll notice that these are randomly rotated, but they still look right. So if I come over here, we can see that, which one's that one? Is that this one here with that indent there is this one, but it's been rotated around, and it will do that randomly. So if we ever get two of the same tile, let's just extrude that out a couple of times, see if we get two of the same tile. There we go, these two are the same tile, but they're rotated randomly. And again, if they're too close to each other, then I can just change the seed, so that's sorted. And if I want, I can also change the seed of the rotation, so we can deal with that. For example, if I go back one, those two are the same next to each other, so I don't like that. Let's rotate them randomly differently. So with these different randomization seeds of our tiles and our rotation, we can pretty much control everything that we want to control here. And this will work really nicely. As we saw, we can just E to extrude that out if we want to do something like a junction. Just going to go into vertex mode and get rid of most of that, just because it's getting a bit difficult to show it on the screen. So let's do that and come back to here. So we've got this pretty much sorted, other than the fact that we do want to make sure that we can boolean this all together. So there's a couple of things we have to do here. The first is, for this to work, we need to realize our instances. Otherwise, this just doesn't happen. They're basically imaginary at this point. You can see them, but they're not there. This will mean that they're actually there. And then we need to boolean these together. Now, if you were doing something simple for this, like I've done this with a fantasy dungeon crawler in mind, like something like D&D, but you could easily do this with something sci-fi, like some nice smooth paneling, or something that looks a little interesting for, let's say, 40k, or some other sci-fi panels that you're going to have down a corridor. But this is quite intensive in terms of mesh. If I come over here and we have a look at one of these and go into vertex mode, there's quite a lot of geometry here because, well, I know my computer can take it, but the one thing it's not going to be able to take very easily is me trying to manipulate this by going into edge mode and dragging out these edges. It's not going to like that if it's always trying to do the booleans as it goes. So we're going to do a little trick with this to make sure that it works okay. We're going to use a switch, and we're going to say that this is the switch that we want when it's false. If the switch is turned off, we don't want it booleaning. If the switch is turned on, we do want this to boolean everything together. So let's bring in a mesh boolean. We want to change that to a union, so it brings everything together. We're going to put our geometry in there. Everything that's joined together is going to combine, and we're going to put that into the true. Then we need to tell it what to look for. So we're just going to drag that out, put in a compare node that has a look if they're equal. And I'm going to put in an input node here. So we've got a group input, which is our general one. And we're going to take this blank into the A. And we're going to say if it's equal to 1, that we want it to boolean together. Now, at the moment, you can see that this means it comes up on our panel at the side. So it's really easily accessible. I'm going to press N here, and I want to change this. So I'm going to change this from name to boolean, question mark. And then I'm going to put the default value as 0, which is no, because we've said that it's only true if the value is 1. So I'm going to change that to minimum of 0. And then we want a maximum of 1. And because this is an integer, that means we can either put this as 0 or 1, we keep it at 0 while we're fiddling around with it. So for example, like that. And it does it nice and quickly. But when we've finally decided that this is what we want, just type in 1 there, and it's going to create our combined together mesh. Now there are a few other things that I probably want to be over here, so we're going to add a few other group inputs. So I'm going to Shift and D that there, and we're going to have a group input for this offset, which is going to be our thickness. Now because this is a minus, I want this to be a little nice to look at, so I'm going to bring in a math node that is going to be a minus, so we're going to multiply by -1, so anything positive becomes a negative, and I'm just going to drag that into there, and I want to change that name of value to be plinth thickness. So we've got that there, drag that into our offset, and at the moment it's down as 0.5. I'm going to change the default to 1, the minimum as 1. Actually, let's do 1, and then the maximum can be whatever, 5. Anything more than that's ridiculous. So I'm going to put that as 2, and that is still extruding down because we've got this multiplication by a minus value. Now in terms of my logic, the boolean should be at the bottom, so I'm just going to drag that one down to the bottom so it's the last thing that we're thinking about. And you'll notice that that swaps it over on all of these nicely. It doesn't cause any problems. Right, so the other things that we want to randomize. We want to be able to randomize our choice of tiles. So if I come to where we're doing that random value and we've got the seed, let's just bring that out, and we're going to go for another input, so group input there, and that's called seed. Let's change that to tile seed. So we've got that there, and we want that again a default of between 0 and, well, whatever, 1,000 or whatever, or 10,000, whatever that is. That's not really an issue. And then we want to change our rotational value seed. So again, I'm going to do that as another input. So group input there, and again that's called seed. That's why it's important that we rename this, and we'll call this rotation seed. And again, default of 0, minimum of 0, maximum of, well, we'll leave it at 10,000. So now at this point we don't need that. Everything is controllable by here. And oh no, I do want to change that boolean to be at the bottom again. So anything I want to shift around, I can move really easily. So E there, let's grab that one, E, and then E. And then if I want to change anything like the tiles, I don't like that, I can change my tile seed, and I can change my rotation seed if I want to as well. So the tiles stay in the same place, but they rotate randomly. And there we go. We've got our dungeon crawler tile generator, really easy to use. Just extrude it out, and then it's going to create a new tile each time, and we can 3D print from this. So as I said, this is available on my Patreon. Feel free to check it out. It's lovely to get that support, and it means that you've got access to these videos ahead of time. So we're a video ahead at the moment, and it means you can watch these ad-free, which is always a bonus. Now, if you've come here just to see how this works, this is the chapter that's going to do that for you, and I'm going to assume almost no Blender knowledge for this, so you know exactly what you're doing. I'm also going to turn off all of my add-ons that would mean I'd do anything in a way that you wouldn't have access to. So you're going to get this, and it's going to look something like that. In fact, I'll hide the tiles so it doesn't cause any confusion. So you're just going to see something like this. Now, to do this, you need to have downloaded Blender. To get that, you just go to Blender and download the current version of it, install it, and then you open this file. So just File, Open, and then you come to where you've saved this. And you're going to have something that looks a bit like this. And to make this work, all you need to do is press Tab, and then that will take you into edit mode. And at the moment, you'll see that there are these dots here. This is because you're in vertex mode. You don't want to be in vertex mode. You want to come up here and select edge mode. So that's all you need to do, and then whichever side you want to pull out, you just click on that edge. You'll notice it will turn a color of white, and then you just press E to extrude this out and drag it out one length. If you go any further, this isn't going to work, so you just need to drag it out one, click, and then if you want to bring it out with another tile, let's move those down because you won't see that, E again, and then E again. If you want to select multiple edges, just select one edge, hold down Shift and select all of the edges, turn to another angle, and then press E to extrude it out. If at any point anything goes wrong, for example, if you press E and do a weird diagonal where this isn't going to work, you can just press Ctrl and Z to undo that, and just E again to have another go. If you want to make this really easy as well, Obviously, you don't have to select multiple edges. You could just select, say, 2 if you wanted to here. If you have a look over in the corner at the top right, you've got what's called the gimbal, and that shows you what direction you're trying to extrude in. So if you want to make life really easy and you know you're going to go in the X direction, you could just type E, and then if you type X, it means you can only get in that X direction, so it's not going to potentially go the wrong way. And then E and X again. So at this point, you're making your dungeon tiles. It works perfectly fine, but you want to make these so these are 3D printable. Now, what I'm going to do now is just tab out of that. So tab gets into edit mode, tab to be out of edit mode, and you can see this green highlight. So let's go through how to save this as an SCL and make it 3D printable. Now I will say on this, if you don't like this layout, for example, you don't like these tiles, you can change the tiles by coming to this tile seed and click, and it will randomize the tiles to different ones. And if you say, for example, don't like the rotation, you can click the rotation seed and it will keep the same tiles there, but they will turn round in different orientations. So you've got 2 controls here. The other thing you can do is this plinth, the bit at the bottom that keeps everything together, is set as 2mm. If you don't like that, you can come in here and type, for example, 3, and it will make it thicker. I'm going to put it back to 2. So what you need to do is the first thing you need to tell this is to combine this together, and you do that where it says Boolean question mark over here. If you don't have this, it's because you've clicked on one of these. You need to come to this one that looks like a wrench, and where it says Boolean, this is set up so that if you type in 1 and then hit enter, it's going to start doing the calculations to merge all of this together. This can take a bit of time, so depending on how powerful your computer is, you might want to leave it a minute. Okay, my computer's fairly powerful, so that was done in real time, but the larger the set of tiles, the longer that's going to take, and it does depend on your computer setup. So do feel free to leave that. Don't try and click on anything while it's working. It's just going to cause yourself problems. Then File, Export, STL, and then you need to select whatever name you want this to be, and you can change where this is saved, but most important, you must click where it says selection only. You must click that, otherwise this is not going to work. It's going to bring in all of the individual flagstones and you're going to have a mess. So make sure that's clicked, click export STL, and you've made your STL. Now, because this is very complicated, there are likely to be some minor errors with this, so let's talk through how to fix those minor errors. So the first thing you want to do is you want to find 3D Builder. You can download this for free if you don't have it, and you're just going to click that and you're going to click open. Now if you've used other objects before, you'll be able to see that, but load object, and you're going to find wherever you saved this to, click on it and open, and you'll find your tiles. You want to make sure this is selected to millimeters and import model, and it's going to have probably a red line around it which says that there's some sort of minor error or defect. Just click on this to repair it. Your computer's going to repair it. Again, speed of computer is going to make a difference, and as soon as that's done, that is going to be repaired. So that was done in real time again. Click save, and then that will fix your saved STL file, and you can bring that into whatever program you want to do your 3D printing. So it's now that easy to create your 3D dungeon tiles. So whether you're going to make this from scratch like I did, or you just want to be able to make these dungeon tiles really quickly, hopefully that has sorted you out. If not, do feel free to ask anything in the comment section, and have a great day, guys.